2x squared minus 15x. Perfect. All right. So that's just a multiply. And the thing that people forget there a lot of times is the x squared, because they'll do these two and they think, oh, 4 times 3 is 12, and then I have an x, 12x. But it's actually 12x squared. Okay, the next one. If you multiply this out, it's just a FOIL problem. I'm going to call on somebody in a second, so be ready. Nope, no hands. I want to call on a random person because everybody's thinking, ooh, it could be me, and hopefully that's ready. All right. Back corner in the blues. First name starts with D. What do you got? You're so right. Okay, that is just first, outside, inside, last. You got to be good at that. Next thing is this. What's special about that? It's just first, outside, inside, last, but what happens? Yes. The middle terms will cancel. So it'll just come down to what? X. Oh, you're so close. There you go. X squared minus 49. Okay, and how about the last one? What's special about that? Some people go, oh, it's just x squared plus 9. But it's not. Yes. Yep. Yep, now I can multiply it out with FOIL, and what do you get? Very nice. Okay, good. So, what are we talking about today? We're talking about parabolas and quadratics. Okay, quadratics always make parabolas. And they can be big, wide parabolas. They can be short, skinny ones. They can be flipped upside down. They can be moved left, right, and stuff. Okay, so generally you have them in general form. And general form looks like this. A typical problem would look like this. 2x squared plus 3x plus 5. That's in general form. That's what you usually see. But sometimes they look like this. And I'll show you an example of what that would look like. Y equals, let's say, 2x minus 3 squared plus 5. Think for just a second about that as a parabola. Do you get that it's a parabola that has been moved here and here? And it's also been stretched. Yes, twice as tall. Vertical stretch of 2. Very good. That's called vertex form. Why do you think it's called vertex form? Probably has something to do with the what? The vertex. So what do you think it's trying to tell you? The vertex of the parabola is at H and K. Which means the vertex of the parabola I made up would be here and here. But the answer to the vertex is not. The vertex is not negative 3 comma 5 on this problem. Want to take a shot at what it would be? What do you think? Regular 3 comma 5. Yes. Why does that 3 not negative? Because you don't trust the stuff on the inside. That's right. Okay. So there's my vertex. And it's been stretched twice as tall. Has not been flipped, or there'd be a negative outside. All right. Let's look at this one. Take a look at the parabola on the board, please. Do you get that by just looking at it, I can see where the vertex is? It's at 3 comma negative 4. You get that? If you're really smart, you can write me the equation for this parabola right now. Try it. I just taught it to you 5 seconds ago, but some of you will already have caught on. The equation in vertex form would be y equals something. See if you can do it. Some of you are that smart. You got it? All right. Tell me what you think it is. You're so right. Nice job. How many of you had it right? Oh, holy cow. I guess I assumed that it would take you longer to catch on to that. That's awesome. All right. What happened to the A? Well, there's no stretch. You know how I know there's no stretch? Because from here to here, it goes through the point 1, 1. So I can tell it has not been stretched. If it had been stretched, that's where I would put it, is right up in front here. But it hasn't. Now it asks for the equation in general form. Well, to get that, all you do is generally you just multiply this out. Do you see now why I asked you to do a couple of those ahead of time? Because you have to remember to not just go x squared and 3 squared. You got to write out x minus 3 and x minus 3 and then minus 4. Know what I'm talking about? That's why we practice that. So go ahead and do that and tell me what you think the final answer is for the problem. What do you do with the minus 4? I bet you'll figure it out once you're done foiling out the first part. Got it ready? What do you think? X squared minus 6x. Shouldn't it be plus 9? Ah, you're right. Just keep going. The 9 goes with the minus 4, and then this would normally make a positive 9. So the 9 and the minus 4 makes positive 5. All right. So that would be a lot harder to just, if I asked you to tell me this equation for it, by looking at it, that'd be tough. But you can do the vertex form just by looking at it. You go, oh, here's the vertex. I know what the vertex is, so I can plug it in here, and then I multiply that out to get the general. Could any of you have gotten this right off the bat without even, like skipping over general form? Do you see any way? I mean, it's got a 6 and a 5. They're not really related to a 3 and a 4 too well, are they? No, you pretty much have to start with the vertex form first and multiply it out. Yes? Nope. Don't worry about that. All right. How about this? By looking at this right away, something jumps out at me. It's trying to tell me something. What's it trying to tell me? Don't these numbers just jump out at you? They jump out at me. Maybe it's just because I've been doing this a long time. So those numbers jump out at me and they're screaming what? They're not screaming hello. They're screaming, I'm the vertex! 3 comma negative 7 is the vertex. Doesn't that just jump out at you? Make it jump out at you. You got to get used to seeing that. If I write you another one, five comma 7 is just screaming vertex. Okay? That's what you need to find when you see vertex form, because the reason they give you vertex form is they want you to know what the vertex is. So here it is. Boom. And I don't use the negative 5, I use positive 5. All right, and then what's this little pesky 3 in the front? It's a stretch. 3 times its tall. Very good. What if I throw in a negative here? Flip. So now I want you to sketch me what this parabola looks like really quick. Just a quick sketch. Just quick. Doesn't have to be super detailed. It's okay if you're hungry. I don't have a problem with that. That's okay too. No problem. One thing you do have to do is remove the lid. All right. So your first thought should have been, I know where this parabola's top or bottom is, and that's at 5, 7. Over 5, up 7. Put it out there. That's got to be the vertex. Now, a normal parabola would go like this. This is not a normal parabola. This is a flipped parabola. So it's like this. And if that's a normal parabola, hasn't this one been stretched? Okay, so you should probably make that thing pretty tight. This is an up-down flip right there. And that did flip over the x-axis. How about if I do it one step at a time? Would you agree that the parent parabola starts there? Okay. And then the next thing is, if I'm going to do them in the right order, the first thing I do is that minus 5, which you moved it where? 5 to the right. Next thing I should do is I go to the outside. And do I do this flip or do I do the stretch? Generally use stretch before you flip. Okay. So then my parabola is going to get all stretched. And then I'm going to flip it. And then I'm going to move it where? And that's how it'll end up in the way the black ones. See? No problem. Just I want to show you that you can walk it through one step at a time to see where it should be. Okay, raise your hand if you had that right. Okay. So then, if they give you this one, it's kind of a trick because they're trying to make you think that that is not any form you've ever seen before, but it is in a form. Which form is it in? Vertex. Vertex, though, general form has got it all multiplied out. This one hasn't been all multiplied out. So this is the vertex form. But that 5, when I move it over here, should I bring the negative with it or not? No. That negative, things that come after a number don't go with the number. So that 5 goes over here, and then what do I do with it? Add. All right, so then, now I can see what my vertex is. What's my vertex? Negative 2 comma 5. Okay, so that's parabola with the vertex there, and it's getting flipped, not been stretched. All right, what if I wanted that to be in general form? That's what the question says. Change the following to general form. Well, then I have to generally just multiply it out. Now, I do like to have that 5 at the end, personally. So I'm going to move that 5 over here. But then, if I do this in the right order, I'll get it right. But lots of kids are bad at that. They just think I'll just kind of do whatever I feel like doing, and I'll, you know, if you multiply that negative in right now, you're going to get it wrong. If you put that negative on both this and that, you're going to get it wrong. There's a lot of little things you can do to screw this up. So try it once yourself. See if you know what order to do it. Please excuse my dear Aunt Sally. Tells you the order. Give it a shot. I'm going to walk around and see who knows what's going on. Yep. All you have to do is multiply it out. So generally, to get general form, just multiply. And hit pause while I walk around and look. Okay, we're trying one more here. Multiply this one out in the right order. For anybody that missed that last one, I'm going to put the answer back up. It was right there. Okay. And now the new problem I want you to try. Is this one. What was the last number of it? Plus 3. Right, so the first thing is this part. X minus 4, x minus 4. Why does that have to go first? Because powers come before anything else. Actually, exponents do, or sorry. Please excuse my dear Aunt Sally. Parentheses do, but there's nothing to do in the parentheses. X minus 4 can't be done. So then I do the exponent next. And then I'm going to do the multiply by negative. And then the last thing I'm going to do is add 3. Okay, so negative, and then all this stuff. X squared minus 8x plus 16. And then a plus 3 at the end. Negative gets distributed. Negative x squared plus 8x minus 16. And then add 3 at the end. And then negative 16 and positive 3 make negative x squared plus 8x minus 13. Raise your hand if you had that one right. Awesome. Much better this time. Almost everybody. Okay. Yes. Yep. 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 If I had a 2 there, are you asking when that would come in? That would be a negative 2 that would stay in the front, and then when I multiplied the negative into everything, multiply by everything by negative 2. Yes. Okay. So that would happen at the same exact time as the negative happened before. What if it's on the inside? Okay. So let's say it was like this. It's a good question. It was like that. One, your parentheses are first, so you go inside the parentheses, you do anything you can inside there. Can I do anything inside these parentheses? Yes, I can. I can multiply that out. So then I'd say 2x minus 6, and then that's squared. This is 2 times x and 2 times... Okay. And then I would multiply out 2x minus 6 times 2x minus 6. Okay. Yes, the order of things is really super important. Okay, look at this one, quick. Just look at it. What jumps out at you? So it's now negative 4, 3. What is it? 4, 3. Good. So right away you should see, oh, the vertex is 4, 3. So if I ask you to graph it, you just go over to 4 and up 3. Boop, put a dot there. And then I know it's a parabola. It's been stretched twice as tall. So it's going to be a little skinnier than normal. It looks like that. See how quick it is to graph parabolas if you use this method? And then if I need general form for it, like I need to know what A, B, and C are to put it in the quadratic formula or something, then I need to generally just multiply it out. So I'd start with this. Once that's all done, I times everything by 2. Once that's all done, I add the 3 at the very end. 3 steps. All right? So that's how you change things from vertex to general form. All right, so here's a question they could ask you. What is the equation in general form? Well, you just take this and multiply it out, just like we were just talking about. Once you're done, you'll have general form. But I could have told the vertex right up by looking at this. You see it jumping out at you? What do you get? Negative 1, negative 2. Okay? And then does the vertex represent a maximum or a minimum value? Well, if you actually graph this thing, if I go over negative 1 and down to negative 2, and I know it's a parabola that looks kind of like this, that a low spot or a high spot? It's a low spot, so it's a minimum. Yep. If it was upside down, that'd be called a what? Maximum. Okay. And then the last thing they ask you is find F1. F of 1. Look at this for a second and tell me, did they tell me what X is or what Y is? Remember that question? They told me what X is. They told me X is 1 by saying this, because that's where X normally goes. So they told me X is 1. Do you get that I could just put a 1 right there? That's where X is. Stick a 1 right there. Well, let's do it quick and see what you get. If I stick in a 1 right there, I'm going to have 1 plus 1 makes 2 squared is, 4 times 2 is, 8 minus 2, 6 is the answer. F of 1 is 6. How could I have got that off my picture? Well, if I go to my picture and I look at over 1, I go up here. If I go over to 1, I go up and see where would it touch. It would touch right there. And I hadn't got there yet. Drawing, but... Okay, that's another way to do it off the picture. They told me X is 1, and what did they want to know? They wanted to know Y. Because that's where X goes. And if they already know what X is 1, they want to know what Y is. So you can find Y by sticking it into this equation right here, sticking the X in there, or you can look at the picture. All right. So we have a vertex to general form worksheet. It's on Schoology, and that's your only homework. Find the one for today's date, which is the 23rd. Vertex to general form worksheet. It's kind of average in difficulty. I think it's got 4 pages, but that just means there's room to write and stuff. So